Our knowledge of factoring the quadratic formula, locating the zeros on our calculator, and synthetic substitution can be used to find the zeros of a polynomial. Now I'm actually going to start with problem 2 because it's the simpler of the two examples. But it says if g of x is x cubed minus 4x squared minus 13x plus 18, show that a negative 2 is a zero of g of x, and then find the other two zeros. So I take negative 2 out here, and I'm going to synthetically divide into this. So I want the coefficients. So in front of x cubed is a 1. In front of x squared is a negative 4. In front of x is a negative 3. And our constant is 18. So the pattern says drop this one and then multiply. 1 times a negative 2 is negative 2. And then we will add these to get a negative 6. And then we will multiply again to get 12. And then we will add to get 9, multiply to get a negative 18, and add to get 0. Now I would expect this to be 0 because they told us this was a 0, which also means they told us it was a 0, which also means it's a factor, which also means it's a root. You'll hear all that thrown out there. Graphically, it means it's where it will cross the x-axis. So this is a remainder. This is our constant. This is x to the first. This is x to the second. So I reduced my cube to a square. No, so that's 1x squared minus 6x plus 9 is what I get when I pull that factor out. And I want to know what the other factors are. In other words, when this is 0, and we can see that this factors into x minus 3 times x minus 3 again. We're giving us a solution of 3 for that and 3 for that. Or in a sense, a double root. And if you remember from the other lesson, that means it would hit the x-axis but not cross it. We would expect 3 zeros because this is a cubic function. They gave us 1. We found the other 2. So these are the zeros of that function.